Hey, ChemStars, this is Mrs. Vandal bringing you another ChemStar video. This is section 7.3, number 7. We're talking about percent composition and chemical formulas. So before we do anything else, go ahead and make sure you have your periodic table with the polyatomic ions on it. And yes, you need your calculator. Yes, again. Oh, we need it every day, don't we? So if you need to pause this, get your stuff out, come back, all right? All right, hopefully you have everything you need, so let's go ahead and do this. We are doing percent composition and chemical formulas, so we're going to solve percent composition by mass, all right? And we're going to find percent composition. Well, let me ask you this before we get started. If I were to ask you, what is the percent of girls in your classroom, what would you do? Well, I bet I'd first count up all the girls, and then I would count up, I'd count up everyone. And then I'd take the number of girls divided by everyone in the classroom, and I'd get a percent, right? Oh, I'd get a decimal, then you have to multiply it by 100. And that's the same idea. So the percent composition is always part over whole. So in the example I just gave you, the part would be, well, how many girls did I have? The whole would be, well, how many people are in your classroom? So it's the number of girls divided by everyone in the classroom, part over whole. Well, we're going to do the exact same thing, but in this time, look up here, we're going to do it by mass, all right? And so we're going to take the mass of the element we're looking for divided by the mass of the whole. Of the whole what? Of the whole compound. So you need to find its molar mass. So that's exactly what I said here. So you're going to find the mass of the element divided by the molar mass of the entire compound, and then don't forget, multiply it by 100%. We have every unit to work out, so we have to do this. So let's start off with what is CO2. Will you go ahead and name that for me? All right, well, what'd you get? Let me do this. I got carbon dioxide. How about you? All right, so I kind of started off on an easy one. So now we need to find the molar mass of CO2. Well, how did we do that in a few sections before? Well, I had to figure out how many carbons I have. I have 1 carbon, and what's the molar mass of 1 carbon? Look it up on your periodic table. You got it out. Yeah, it's 12.01. And now I have 2 oxygens. What's the molar mass of oxygen? It's 16.00, and I'm going to add them together, and this is what I got. All right, so my molar mass of carbon dioxide is 44.01. So now I need to find part over whole. All right, so part over whole, and then times 100%. That's what I'm going to do. So what part of CO2 is carbon? Well, I think it's right here. Isn't it 12.01? And then what's the whole? It's right here. It's 44.01. Let me get that down here. There you go. So it's 44.01. And now what? Well, I'm going to divide. Go ahead and use your calculator. What's 12.01 divided by 44.01? Okay, this is what I got. And then don't forget, you have to multiply that by 100%. So when you multiply by 100%, just move your decimal place over 2 spots, and I got 27.3% carbon. Now, let's talk about sig figs real quick. And when you're doing percent composition, there aren't any sig figs, all right? You're not taking any direct measurements, are you? You're not weighing anything, you're not finding the volume, you're not counting anything. So there are no rules for sig figs. So I'm just going to say, let's just go ahead and make it always go to 10%, all right? So it's going to be something point something. All right, so I'm going to go to the 10th place in my percent just because, all right? All right, next, oxygen. Well, how much of it's oxygen? Here it is. It's 2 times 16, isn't it? Yep. And you're going to divide it by what? Part over, what I say? Part over whole. So it's 44.01. So what's 2 times 16? I think that's 32, isn't it? 32 divided by 44.01 is what? Go ahead and use your calculator. I got 0.727. Don't forget, you have to times that by 100, and you got, move your decimal place over 2. I got 72.7%. Now, this is really important. What do these numbers add up to? All right, so 27.3% plus 72.7% adds up to 100. And here's a hint. It should always add up to 100%. Okay, so that's an awesome check right there. So add up your final results, and if they add up to 100, I can't say you'll never have made a mistake. Maybe you made another mistake along the way, but it's at least encouraging they didn't make a lot of mistakes. All right, so anyway, they should always add up to 100%. Let's go ahead and do the next one. What's this next one called? This one is ionic, isn't it? And I see a metal silver. Silver is a what? Always, always, or wishy-washy. Do I need Roman numerals or not? So go ahead and think about that. And is it binary or polyatomic? I think it's polyatomic. How do I know that? I see 1, 2, 3 different elements. It has to be poly. So, oh, I need that chart, don't I? So go ahead and name that. I got silver carbonate. How about you? All right, so now we need the molar mass. Go ahead and you do the molar mass and pause this, and when you're done figuring out your molar mass, come back. I'll wait. All right, welcome back. Did you figure it out? This is what I got. And I just want to put it out there. I don't know if the periodic table I'm using is the identical one to the one you're using. So if my numbers are a tad off, it's because I'm actually using a periodic table I found on my phone. So if it's a little bit different from yours, maybe these digits might be a tad off. I'm not really sure. But hopefully the process is still the same. Our answers are going to be awfully close if my periodic table is different from yours. So now what? How do we find the percent composition? It's always percent over whole times 100%, right? So how much of this is silver? Well, this is the mass of silver, isn't it? So there's my part. This is my, oops, whole. I forgot my ratio sign. There it is, there it is. So it's part over whole. Now what am I forgetting? I have to multiply that number by 100%. So go ahead and calculate away and see what you get. All right, so what I get? I got 0.7823. So when I multiply it by 100, I got 78.2%. I don't need to round up, do I? Go ahead and do the next two totally on your own and see what you get. Set it up, show all your work. All right, welcome back. Hopefully you paused it and actually did it instead of waiting for me. You're going to learn a whole lot more if you try it on your own instead of just copy down what I do. So here's my part that's carbon. I only had one carbon in my formula. Here's my whole, and so therefore there is my fraction bar. There you go. And multiply by 100%. And what did I get? I got this and multiplied it by 100%. So what happens at 5 is going to round up that 3, so I got 4.4%. To do oxygen, all right, I have 3 oxygens in my formula, and then I'm going to divide, well, keep not getting that fraction bar, divide it by the whole, that 235.75, and when I use my calculator, I got this, don't forget, oh, times 100%, and I got 17.4%. I just want to show you something. I should have mentioned this earlier, but why are units so important? Okay, notice what happens. The grams cancels out, don't they? So if the grams cancel out, all I have left is the percent sign. Grams cancels out, so all I have left is the percent sign. And once again, hey, guess what? Grams cancels out, and all I have left is the percent sign. So they're my units, okay? What do you think I ought to do real quick before I move on? I think I ought to check my work, don't you think? So I'm going to take that 78.2%, add it to 4.4%, add it to 17.4%, and guess what they all add up to? Oh, 100%. I think I did it right. All right, what about this next one? You need to name it first. All right. Oh, guess what? Iron is in the D block. It's a transition. It's not zinc, cadmium, or silver. So you need a Roman numeral. And we have a polyatomic ion. So go ahead and name it for me. Oh, wait. All right, did you get this? Iron, Roman numeral 3 sulfate. See that 3 down below here? That's that 3 Roman numeral because we crisscrossed, and that's where that 3 came from, the charge of iron. Oh, that doesn't go away, does it? Sorry. So go ahead now and you do the molar mass. I'll wait. All right, did you do something like this? I took 2 irons at 55.85. Remember, with this parentheses, I have to distribute that 3 throughout, so I have 3 times 3, 2.06 grams. And now I have 4 times 3, I have 12 oxygens, all right, to get 330 or 399.88 grams. Hopefully my math is right. And now what? We have to take and find the molar mass of everything. Or I'm sorry, you have to find the part over the whole. We already found the molar mass. Silly Mrs. Vandewey. All right, so, and then multiply by 100%. So let's go ahead and do this. Well, what's the molar mass of, or what's the amount of iron? And what am I going to divide it by? Ha, grabbed it. Divide by the whole, right? Times 100%. Why don't you go ahead and do the rest of this problem on your own and see what you get? All right, welcome back. Well, how'd you do? Well, hopefully the first thing you did is divided that out, multiply by 100%. Oops. And I did not have to round up because that 3 is smaller than a 5, so I got 27.9% of iron. And what about the sulfur? Well, I took the part that's sulfur and I divided it by the whole at 399.88. That's a pretty big molar mass, isn't it? And then I multiplied it by 100%. And I got 0.2405 times 100% equals 24.1%. I did have to round up, by the way. Okay. And then for oxygen, I took the part that's oxygen, 12 times 16. That's going to be a big number, by the way. All right, here's my whole. There's my divided by sign. Don't forget you have to multiply by 100%. So I got 0.41801. And did I need to round up the 0? No, not at all. So I got 48%. And what's the last thing I ought to do? Add them all up, and guess what? Voila, they add up to 100. So once again, notice my grams cancels out, and my unit is percents. Okay, let's go to the next page. Okay, so this page we are going to do together in class, so we're going to go to the next page. All right, so we're going to be using percent composition as a conversion. And again, what does percent means? It means per 100 or out of 100, okay? So we're going to do 1 and 2 together in class after we do that activity. So let's go ahead and do number 3 right now. All right, so how many grams are are in 33.4 grams of this rock of iron? All right, so if I have this molecule, this compound that has iron in it, how much iron itself, how much iron metal is in this compound? And again, why might this be an important question? Well, if I want to mine the iron ore to get the iron out of that, I want to make some steel, I guess, all right? So it's really important that you know how to figure out how many grams of iron are actually in the iron phosphate. So I'm going to use percent composition again. Well, what did I have to do every time to figure out percent composition? It's part over what? Part over whole. I need the whole. I need the molar mass. All right. So there's my molar mass, and I got 357.49. Again, I got 3 irons and 2 phosphoruses and 8 oxygens. Okay. I add them up and I get this number here. Okay. All right, so hopefully that works out for you. So now what? We want to find out how many grams are there in nickel. So there are 2 ways to do this, all right? So the first way is let's use percent composition, okay? So let's find the percent iron. Go ahead and find percent iron. You have everything you need to know. Go ahead and do that. Pause this. All right, hopefully you got that. So it's always part over whole. So I have 3 times 55.85 divided by, I'll get my divide by thing, over here, the whole of 357.49, right? then multiply that by 100%, of course. So what did you get? I got this number. Well, that's kind of overkill, isn't it? I'm going to multiply by 100 though. So I end up with, I want to go 1, 2, 3. I'm going to have to round that 8 up to a 9. So I got 46.9% iron. So how is this going to help me? All right, well, I want to find out, how many grams of iron I have in my sample here. So let me pull this up here. How many grams of iron? I start off with 33.4 grams of the iron 3 phosphate. I'm sorry, iron 2 phosphate. Notice I'm putting my units down. I'm writing out the entire formula, all right? You've heard this from me before. One of my favorite phrases is, don't be lazy, write it all out, okay? Don't take shortcuts here. This is what factor labeling is all about. So I need the grams of the entire thing, okay? And guess what's going to go on the bottom? Grams of iron 2 phosphate, okay? And if I'm going to use percent composition, what does percent mean? Per 100, all right? So what does that mean? If I had 100 grams of this sample, 46.9 grams of it is iron. See where I get that number from? Right here, okay? So I'll say it again. If I have 100 grams of the entire sample of the iron 2 phosphate, 46.9 grams of it will be iron, okay? So then take 33.4 times 46.9 divided by 100, and I got this, which I got 15.7 grams of iron. So I said there were two ways, all right? And I would use this way if I already know the percent. So hint, hint, you can probably do questions number 1 and 2 above this question tomorrow after we figure out the percent composition of the ores that we're going to do in class, all right? So I would probably approach the prior 2 questions by doing the method we just did. You've already figured out the percent of your ore before, so why recreate the wheel? But if, like in this case, I don't know all the different percentages, this is how I would approach this one the second way. So here's way number 2. So how many grams of iron are in 33.4 grams of iron 2 phosphate? All right, here's this again. I would save yourself a little bit of work. And why would I do that? You're less likely to make a mistake. So if you don't know the percentages, did you write that down? I would use method 2 if you don't already know the percentages. Write that down. That's pretty good. All right. And I forgot the word or. So what would I put on the bottom? Grams of iron 2 phosphate. Look at the units. All right. They're the same units. Where did this number come from? It's the molar mass. Do you see that? That's the molar mass. Well, how many grams of just iron are there? Well, what's 3 times 55.85? I got this. All right, do you have your calculators? Do this for me. What is 33.4 grams times 167.55 divided by 357.49? Go ahead and do that. Shockaroonies, all right. With 3 sig figs, you get the identical answer, just like before, all right. So that works out. Again, I want to show you something about the units. Notice how the grams of the iron 2 phosphate cancel out. All I have left is grams of iron, and that's what I want, is grams of iron. All right, notice again, grams of Fe3PO42 cancel out. I have grams of iron left, and that's what I want. So it all works out. Factor labeling is a wonderful thing. All right, let's look at number 4. Okay, how many grams of nickel are in 50 grams of nickel 2 chlorate? I had to stop and think. So no matters how you do it, guess what you need to figure out? The molar mass. You're right. Go ahead and figure out the molar mass right now, please. All right, this is what I got. And I added it together. I hope you got that too. Hopefully I didn't make any boo-boos. So now what? How do you think I'm going to do this problem? Well, I don't know the percent composition of nickel, do I? I haven't previously figured that out. So I'm not going to do any like extra work. I'm just going to do it the original, or the second way I did it in the prior example where I did not know the percent composition. So how many grams of nickel are there? And what's going to go on the bottom? Well, grams of nickel 2 chlorate, which happens to be 225.64. That's the molar mass, okay? Well, how many grams of that is nickel? Well, isn't that what this number is up here? So I have 58.71 grams of nickel. See, that's where this is. That's your grams of nickel. So what's going to happen next? Grams of nickel 2 chlorate, grams of nickel 2 chlorate cancel out. What's the unit left? Grams of nickel. Grams of nickel. Life is really good right now. So go ahead and go 50 times 58.71 divided by 225.64, and what do we get? All right, that's what I got. Oh my goodness, Mrs. Vandal, that's too many sig figs. I know. How many sig figs do we need? 4. 1, 2, 3, 4. Oh, that 1 needs to round up to a 2, doesn't it? And there you go. All right. Why don't you do number 5 all by yourself? So pause this whole thing, all right, and go ahead and figure this out. All right, welcome back. Hopefully you paused this and did the whole problem. It's not that hard, I hope. Well, the first thing I'd know what carbon tetrachloride is, right? Well, hopefully you knew it was CCl4. I gave you an easy one. And the molar mass, well, I have 1 carbons and 4 chlorines. So if you didn't get your formula right, you're not going to get the problem right. Okay, so hopefully you got that right. And I got 153.81. So do you know the percent composition of carbon? Not at all. Okay, so I'm going to do it that second way that I showed you. So here is the grams of carbon. I have 150 grams of carbon. Oh my goodness, I wrote CH4. That's silly, Mrs. Vandalay. It's not CH4, it's CCl4. All right, that was silly. Sorry about that. I fixed it. Anyway, so I have 150 grams of carbon tetrachloride. So now what? I go here. So what was my whole? All right, was 153.81. There's my total. Notice I can do this, that my grams of carbon tetrachloride is going to cancel out. And what am I left with? Well, I need grams of carbon. There I go. So 150 times 12.01 divided by 153.81. And I got this. All right. And now what? Well, that's too many sig figs. I only have 2 sig figs here, so I end up with 12 grams of carbon. How'd you do? All right, that concludes ChemStar 7.3, number 7. I hope this was helpful. If you have any questions, make sure you ask in class. Watch it again. I tried to, explain the best I could. So hopefully it was helpful. Don't wait to be great. We'll see you next time. Bye-bye.